Okay, this is where we left off. I asked you to do some problems, and then especially get the number line. We kind of had to finish that number line. We talked about between. I addressed between. It's important because whenever I see a point is between, we're going to use the segment addition, which basically means I'm going to do some type of adding. And so I went ahead and labeled the figure for number 4 and set up the equation. We solved for x, plugged it back in. We talked about, remember, a figure can not be drawn in scale, so it's okay. And then I asked you to draw the relationship to go with, a figure to go with, number 5. Since if n is between m and p, so we have m between, it doesn't have to be at the middle, it's just between. We go ahead and label. So let me get this set up nice and big. So I need to write the equation, and then I wanted you to try to see if you could solve the equation. And we should have gotten a fraction answer, and I think we'll just make sure you have the right answer. If I solve the equation and simplify, we get 8x plus 8 equals 30. And then basically if I subtract the 8 on both sides, we get 8x equals 22 divided by 8. X equals 22 over 8, which can be reduced to 11 over 4. Now, I had some students ask if they could write that as a decimal. You're more than welcome to do so. You can have it as a decimal, but because you're going to solve and have to plug it back in, you can keep it as a fraction to help simplify your results. You can plug back in. But if you got 2.75, that's fine. And just plug that 2.75 because they want you to find the measure of mn right here. They want mm. So that means you're going to have to plug it in. Mn equals, I can say 6 times 11/4 plus 5. Oops, I'm running out of room. Sorry. Or I can say 6 times 2.75. Plus 5. I think I ran out of room again. There we go. Alright. So, hopefully when you do that, you get that mn is going to be 21.5. So, if mn is 21.5, and I already know the whole segment is 30, you do mental math, just subtract to find the missing segment NP. And that would give me 8.5. Okay? So in the habit of once you have the value for x, you plug it back in to get the segment length. All right, then I asked about algebraic expression to represent g to k, and I was hoping that you would see that hi, this segment is overlapping, and it's not congruent. I probably shouldn't take marks because we're going to get into that, but it's overlapping. And GJ and HK. So because it is overlapping, to come up with the expression, I'm going to add all the parts. This is overlapping in both, so I'm going to have to take that part out. I'm going to have to take this X part out of both segments. So I would have GK is going to be 2x plus 3, but then I'm going to take away that X, then add the 4x minus 3. Or I could just simplify and see that GK is 5x. So they want us to find GH and JK. Well, since I know GK is 30, then 30 is going to equal my 5x, and I see x is 6. And I can plug that value back into our measurements here. So I can do 2 times 6 plus 3, so we know that G to J is 15, and then I can plug it in for HK as well, 4x minus 3, that would be 24 minus 3 would be 21, okay? So now they want us to find G to H. Well, if I know G to J is 15, and I take out H to J, which I know is 6, so 15 minus the 6, GH is going to be 9. So we know that part right there is 9. And then they want us to find JK. Well, I know already from GK. So this right here is 30. And so I can see that JK, if that's 15, this is going to have to be 15 as well. Okay? So I'm just going to plug it in. Now, some terms that you need to be familiar with and some markings we need to talk about. Make sure you have a good understanding of will be congruent segments, segments that are equal. We have a symbol to show that, and basically it's an equal sign and then like a little sideward S maybe on top. I think you probably have seen that before. But if I want to show congruent, which is right here, then I have to see hash marks on the figure to show congruent, okay? And they have to be the same number of hash marks. So if you look over here on this rectangle, the top and the bottom have the same hash marks too. So those are congruent, which is a property of a rectangle. It's a parallelogram, so opposite sides are going to be congruent. Well then if I look here, the left and the right have only one. So those two are congruent, but not all four. Now, being that we know it's congruent, then we can, or how to mark congruent, or what congruent segments are, we can have a better understanding and apply the definition of midpoint. Okay, midpoint is a point that divides a segment to two equal parts. So if I see these tick marks here, I see my two equal parts. It is PM, segment PM is congruent to segment PQ. And I can see that that point M is the midpoint, okay? Based on the markings. Now, you cannot assume midpoint. You can't assume that a point appears to be the middle. The only way you know it's the midpoint is by seeing the markings, okay? You must have the markings in order to prove or justify midpoint. So a midpoint on a segment will divide the segment into two congruent segments. The midpoint bisects the segment. So another way, a bisector could be a midpoint, could be a line, could be a ray, it could be another segment, but it's going to cut it in half. And in order for me to understand or see a bisector, because in this example, O bisects the segment, it is the midpoint, I must see the tick marks. So besides knowing that you have two congruent parts, you need to also know the relationship. Okay? And I don't know if an arrow looks, but if I know that DO, segment DO is congruent to OG, then I also should be familiar that the segment DO, or the length of DO, is equal to, notice I didn't put a segment because I'm talking about the length. The length of DO is equal to half the length of DG. So if I cut the segment in half, I have my two equal parts. And I could say if I double, so if I take 2 of the segment, or the length of DO, excuse me, it would equal to the length of DG. Or I could also say OG, if I double OG, it would also equal DG. Okay, so make sure you know that relationship as well. And so you're going to use that relationship to problem solve and to apply the definition of midpoint or bisector. So it tells us in this problem that U is the midpoint of XY. The reason why I know that is I have tick marks to justify that, to prove that. Okay, and so it says if XY is 16x minus 6, so basically the whole segment is 16x minus 6, that's XY. And it says if UY is 4x plus 9, so it's find the value of x and then the measure of xy. So right now, this is back what I was saying. If I know just the part, I know that I could double, uy is the same as xu. So there's two ways I can do this. I could say that I can double uy and it would equal to xy. Or I have to, since I see this tick mark to represent uy, then and I don't have an expression to represent xu, I would know that it would also be at 4x plus 9. So I could say xu plus uy equals xy. Alright? Now, I just realized we need an equation because we have to solve for x. So basically, if I'm going to double it, I can say if I double the 4x plus 9, which is just adding it to itself, it's going to equal to the 16x minus 6. So just going to solve the equation, use your distributive property. We have 8x plus 18 equals 16x minus 6. And then solve for x. Subtract the 8x, that would give me 8x. Add the 6, that's 24. So 3 is equal to x. Okay? If you're not sure about the solving the equation part, because I'm kind of skipping some steps, please make sure you get clarification of that. Maybe come see me in the morning or after school. So now that I have the value of x, I can find xy, because xy was the 16x minus 6, and I can just plug it in. 16 times the 3, which was x, minus 6, which is 48 minus 6. So we know that xy is 42. The length of xy, 42. So the same relationship that you use with midpoint, you're going to use with the bisector. Because a bisector can be a segment, a line, or a plane, but it intersects at its midpoint. Okay, so in this picture here, in this example that I've given you, line T is a segment bisector. So the segment bisector is the line. It is bisecting segment XY because I see the tick marks, which tells me that it's going through the midpoint, which is M. Well, if XM is 3x plus 6, and MY is 2x plus 14, and both of those have the same marking, then I know that XM is equal to MY. Or the segment XM is congruent to the segment MY. And if they're congruent, they're equal, and if they're equal, they're congruent. So I can solve for X and to help me find XM. So 3x plus 6 equals 2x plus 14. Well, you work it out, you get x equals 8. And then XM is equal to 3 times that 8 plus 6, which means XM is 30. Alright, so that's dealing with midpoints and bisector. Now, sometimes you could have a midpoint on a number line. Okay, finding a midpoint on a number line. The midpoint is the average of the coordinates. Okay, basically the endpoints of the coordinates. So if the midpoint is between A and B, if I add the coordinates and divide it by 2, I can have its average. Now, this is a skill, an average I know you're familiar with. So we just want you to apply it on the number line. So find the midpoint between the following coordinates. So they just want you to say, okay, if you're at 2 and 8, what's the midpoint? Well, you just add the 2 endpoints and divide it by 2. So the midpoint is 5. I think you can do these. Go ahead and do those. We will check them in class. Okay? What I want you to make sure you know is how to find possible coordinates on a number line. Think about a number line. It extends forever in either direction. So it says point I is between points W and N on a number line. If the coordinate of W is 5, while WI equals 7 and IN equals 10, find all the possible coordinates of point N. We know N is between W, or it says all possible coordinates should be for point I. And I think I wrote that wrong. So we need to start off with the number line. We know I is between W and N. So I could start with, here's W, here's I, here's N. It's between them, right? I know that from W to I is 7, and from I to N is 10. That's the links, okay? They're links, the measures. So if I'm starting at 5, let's say I'm starting at 5. Here's my coordinate. And I go to the right, I would add 7, and that would give me 12, right? And then add another 10, and that would give me 22. So yeah, they want us to find the coordinate of N. N would be 22. That's if I'm going to the right. Because I have a number line, I can move to the right on the number line, or I can move to the left of the number line. Again, let's say we have W, I, and N. And we already know WI is 7, IN is 10 again for their links. I'm starting at 5. So if I'm at 5, I move to the left, that's minus 7. That would put me at, is it minus 7? Yeah, sorry. Negative 2, sorry. And then if I move another 10, that would put me at, if I'm going to the left, 10, a negative 12. So our coordinates for N could be 22, or N is a negative 12. All right, I want you to, I thought there was another one you had to do, sorry. All right, oh yeah, you have it to do on the practice. So what I want you to do is let's looking at a fourth. You had a problem like this on your pre-assessment, and the majority of you did very well on this. So if you have a number line, the coordinates are P, Q, R, S, are negative 10, negative 3, 0, and where were we? A negative, 6, sorry, respectively. Basically, that just means in the same order. So if you had a number line and you had them P, then Q, then R, then S, then respectively in the same order, P would be a negative 10, and I probably should have did that the other way. Negative 10, negative 3, 0, and 6. So they said point V is 1/5 the distance from point P to R. So from point P to R is 10, and we want 1/5 of the distance. So we could look at this as just saying V is 1/5 of PR. Basically, I'm just taking 1/5 of 10. Oops. So V is, and not V is, but V is 10 units away. Okay? Because we would 1/5 of 10 is 2. So I would take 2 units, and I would see that V is really 8. And that's a negative 8, sorry. So is that a negative 8? Or I could do it as a proportional relationship. So I could look at, well, we're trying to compare P to V, because we're trying to find where this point is, out of P to R. And I know it has to be 1/5. Okay, because that's the distance, the ratio. Well, I don't know what P to V is. That's X. I know P to R is 10, 1/5, and cross multiply. I get X is 10, is 2, and then again, if I move it to units, we get V is a negative 8. All right, so there's your notes. I do want to do the practice. We're going to check that in class. Hope this gets everyone up to par. Thanks.